All right, welcome to the video on finding the area of circles and the area of sectors. Okay, a sector is just a chunk of a circle. All right, so bell work wise, again, we're just going to revisit the circumference and arc length. The equation again was AB is equal to the measure of AB over 360 times the circumference, or 2 pi r. Okay, and again what this gave me was this is the length from here to here. This was the measure of AB, which is this central angle. And then this is the circumference. So notice that we're looking for the circumference. So as I did with the previous video, I'm going to replace this with C. Okay, because again, that's what we're looking for. All right. So instead of this equation, I'm going to use AB is equal to the measure of AB over 360 times C. Okay, and again, plugging in things that I know that this is 100. I know the measure of AB is again that 95. And we'll multiply by that, by the circumference. Okay, again, you have two options here. I can multiply both sides by the reciprocal, or I can go ahead and just reduce. I say let's go ahead and just reduce right away. If I take 95, and I don't know why I changed 95 over 360 to 95 over 100. So 95 over 360, if you get the pen out. Goodness. Okay. Let's multiply both sides by the reciprocal. Okay. If I multiply both sides by the reciprocal, again, I'm going to multiply by this flip, so I get 360 over 95, 360 over 95. These would cancel, these would cancel. That leaves me just C on this side, equals 360 times that 100 over 95 times 1, or just 95. Okay. Again, then I'm going to reduce the 100 over 95. I'm going to divide both of them by 5. That gives me C equals, let's move the C over here, again, so we can expand this way. That leaves me 360 times 20 over 19. If I take 360 times 20, I get 7,200 divided by 19, which again is not a nice decimal, so we're going to leave it just like that. Okay. Number 2 is then asking for the length of SP. So again, we're going to go back to this equation, the original one, and we're going to plug into that and find out what the length of SP is. So again, the original equation, we'll just use SP now instead. SP equals the measure of SP over 360 times 2 pi r. And if I plug in what I know, we are looking for the length of SP, so I don't know that. I do know that the measure of SP is this 130, the central angle, over 360 times, and again, I'm going to turn this into a fraction, if I can get it correct, times 2 pi times the radius, which was 14, over 1. Okay. And to do some simple math here, remember that if you have something fraction-wise that has zeros at the tail end, you can cancel respected zeros. So I'm going to cancel this 0 here with this 0 here. Okay, and then I'm going to reorder things now. So I have SP is equal to 13 times that 2 times that 14 over 36 times 1 is 36. And then I still have that pi symbol out there to work with. Okay, and then again, I'm going to just continue simplifying here. So 2 and 36, I can reduce by 2. So it's 13 times 14 over now 18, because 36 divided by 2. With the 14 and 18, I can then again reduce again by 2. So I'm going to divide by 2 there. So SP is equal to 13 times 7 over 9 times pi. And if I take 13 times 7, I get 91. So SP is equal to 91 over 9 pi. And again, that is now my simplified reduced fraction. Okay? All right, as stated, this is about area, so similar circumference, I'm going to break it down to where it's the holistic area. And then the sector area, so that we have just a small chunk. Okay, so the area of a circle is the measurement of the surface covered by an object. All right. The equation that you should know and be familiar with is A equals pi times the radius squared, or A equals pi r squared. So 2 examples here to work with. One, notice that I'm looking for the radius. And then the other one, number 2 there, I'm looking for the diameter. Okay, so these are going to be a little bit different because again, we only have the one equation to work with. So what I'm going to do is I'm going to just reverse this. So A equals pi r squared, or I have pi r squared equals A. Okay, you'll see why I'm doing that. Again, I just want to trail things down that way. All right. I do know the area as 105. So I have pi r squared equals 105. That 105, then I can divide both sides by pi. Which is going to cancel my pi's here. Okay, so that's going to give me r squared equals 105 over pi. Okay, but again, we need the radius. I don't need the radius squared, I need the radius itself. So in order to get r by itself, I need to take the square root here. And if I had a fraction, I said that you have to take the square root of the top and the bottom separately. Okay. I also stated before that we're going to have to worry about the principal and the negative roots when it comes to things like this. But again, we're looking for a measurement of a radius. I can't have a negative length. So we're not going to worry about that negative principal, the negative root. We're just going to worry about the principal roots. Okay. Square root and the square cancel. However, on the fraction there, we have pi square rooted in the denominator. I need to have that not there. I need to have not a square root. Okay, so I'm going to multiply the top and the bottom by the square root of pi. Which is going to give me then that r equals square root of 105 pi again, undoing my multiplication property of square roots, and then square root of pi times the square root of pi is just pi. Okay. Number 2, the area of a circle is 45 inches squared. Find the diameter. So here this is a little bit different. The relationship again between diameter and radius is that the diameter is 2 times the radius. Okay, so if I find the radius, similar to exactly how I did number 1, then I can just take that and multiply it by 2 to get my answer. Okay, so this one, I'm going to do the same thing I did up there. I'm going to have pi r squared equals the area. Again, that's 45 now, so I have pi r squared equals 45. I'm going to divide both sides by pi. Again, that's going to cancel my pi's here and give me r squared equals 45 over pi. Okay, and again, I'm going to take that square root here, just like I did above. Again, now the numerator and denominator separately. That cancels here, giving us that the radius, let's multiply by square root of pi, like we did up top there also, so you're not confused. Which gives me then that the radius is equal to the square root of 45 pi over pi. Okay, but again, I'm asking for the diameter, not the radius. So you have 2 options here. I would take diameter equals, and you can put a big 2 in front and do square root of 45 pi over pi. Or you can put the 2 up in the numerator, 2 square root of 45 pi over pi. Okay, I would take either one of these answers. Again, just be your own advocate there. Which one feels a little more comfortable to you? Not that either one of them probably feels great, but pick one and go with it. Okay. Continuing on to now the area of a sector. The area of a sector. This equation should look very familiar. Okay. In the previous exam or previous lesson, I did the circumference and the arc length. Okay, this equation should be almost identical to arc length, right? The area of a sector is equal to the measure of AB over 360. Again, that's telling me how much of this circle I actually want to look at. And then the back end there now, because we're talking about area, is not circumference, it's the equation for area. So pi r squared is the area of the entire circle. Okay, so again, that's what keeps it distinguished from the length equation, is that this is now area, not circumference. Okay, so 4 examples to work through here. Number 1, let me go ahead and take this out a little bit so we can have some room to work here. Okay, again, the area, and now I'm going to write this a little bit different. So area, I'm going to put SEC for sector equals the measure of AB over 360 times pi r squared. And then again, I'm going to go ahead and plug in everything that I know. I know the measure of AB, again, is that central angle, that 35. So the area of the sector, SEC, is equal to the 35 over 360. And again, I'm going to turn this into a fraction. I'm going to have pi times that 8 squared over 1. Okay. Next line down, I'm going to have area of a sector. I'm going to move things around here. I have 35 times, I'm going to put this 8 squared, which is 64, put that over the 360. That's 360 times 1. We're just going to put pi right there next to it. Okay. I'm going to divide 64 and 360 by 8. Which is going to be the area of a sector is equal to 35 times 8 over 45. Okay, and again, piece this apart as you need to. Take it as much time as you need. If you need to look at it and say, okay, 64 and 360 are even, and just divide by 2, that's fine. Divide by 2, then divide by 2 again, then divide by 2 again, and then we would be here where we're at. Okay. Now 35 and 45 have something in common. I can divide both of them by 5, so I have area of a sector here. If I divide this by 5, I get 7 times the 8. And if I divide 45 by 5, I get 9. And then pi, which then I don't have anything else I can reduce, so I take 8 times 7, which is 56, over the 9 times pi. Okay, and again, this is a simplified fraction, left as a mixed number, but reduced as much as we can possibly get. Okay. Number 2, again, same thing situation-wise. We have the area of a sector equals the measure of AB over 360 times pi r squared. And again, plugging in everything that I know, so I know the radius here is 10. I know the central angle, or the measure of AB, is 160. So area of a sector equals 160 over 360 times, and again, I'm going to turn this into a fraction, so pi times 10 squared over 1. Okay. Here then again, I'm going to shift things around. So area of a sector equals, I'm going to reduce this again like I did last time. If I have zeros respectively, I can cancel those out. So that gives me 16 times 10 squared over 36. You can put that pi symbol next to it. If I take 10 squared, I get 100, so the area of a sector equals 16 times 100 over 36 times pi. Then I can look at the 36 and the 36 and the 16. I can reduce those by 4. So area of a sector, 16 divided by 4 is 4. Times that 100. 36 divided by 4 is 9. And again, times that pi. Here, the 9 cannot go into 4, can't go into 100, and I can't reduce it anymore by any other number. So then my area of a sector here, 4 times 100 is 400 over 9 pi. Again, I understand things like this is a hard process. This is not something that you're used to. Plug it in, take it step by step. It's all based off things that you've done before. It's reducing fractions. Okay, break it down. Sometimes the calculators do it for you, sometimes they won't do it for you. Okay, sometimes it doesn't like them because the fractions denominators are so large. Okay, there will be some things that get a little crazy. All right. Moving on. Number 3 and 4. Okay, so here you'll notice that I give you the actual area of the sector and I give you the central angle, but now I'm asking for the area of the circle. Okay, so again, similar to what we did with that last equation for the arc length, this says area of a sector is equal to the measure of AB over 360 times pi r squared. Okay, and again, what pi r squared is, this is actually the area of the circle. So if I'm finding the area of the circle, why would I plug in, find the radius, and then plug back into the area to find the area? Okay, so I'm going to replace this and just write area of a sector is equal to the measure of AB, or again the central angle, divided by 360 times the area, and I'm going to write circle. Okay, so keep them separate. Make sure you understand which one is the area of a sector and which one is the area of a circle. Okay, and we plug in the information we know. We know the area of a sector is 125. So this is going to be 125. I'm going to put this over 1 is equal to the measure of AB, which I forgot my arcs over here. Let's go ahead and tack them on there. Measure of AB here was the central angle again. That's 55 degrees over 360 times the area of a circle. Okay. And again, what happens here is I'm going to multiply both sides by the reciprocal. Again, you have the option of dividing by the 55 over 360, but I'm going to multiply by 360 over 55. Which is going to give me 360 times the 125 over 55 is the area of the circle. Okay, I'm going to take the 125 and the 55 in the denominator. I'm going to divide both of those by 5. Okay, so that's going to give me 360. Let's write this again. Again, let's flip this around now. So I have the area of a circle, so I can work it out this way. And if again I divide this by 5, that's going to leave me 360 times 25 over 11. And if I take 360 times 25, I get 9,000 over 11. Okay. Understand, some of your fraction answers for these are going to be really wild. Okay. But it's okay. Put down the answer and let me know what it is. Okay. You may have to reduce step by step. You may not be able to plug the whole thing in. Give me the fraction where it's a nice number on top divided by a nice number on bottom. Okay, it doesn't matter what that number is, but again, when you plug this into a calculator sometimes, unless it's only 3 values in the denominator, so if it was like 125 in the denominator, then that would be okay. But as soon as we get past 3 places in the denominator, then it doesn't like it. So it won't do 1,000, it won't do 4,000, it won't do anything higher than that. Okay, so leave it as a fraction. That's a nice fraction. Second one here, again, same thing. I'm just going to replace this right away because we have it sitting there. So I'm just going to rewrite area of a sector is equal to the measure of AB over 360 times the area of the circle. Again, plugging in what I know, so the area of a sector there is 720. And again, I'm going to put it over 1 equals the measure of AB, or the central angle, over 360 times the area of the circle. Again, at this point, I'm going to multiply both sides by the reciprocal of the fraction on the right-hand side. Okay, which gives me 360 times the 720 over 115 is the area of the circle. Okay, and I'm going to divide the top and the bottom by 5. Okay, so I'm going to do the 360. I'm going to do the 720 and the 115 by 5, which is going to give me 360 times 144 over 23 is the area of the circle. And if I take 144 times 360, I get 51,840. So 51,840 over 23 is my area of the circle. Okay, again, not a friendly looking fraction. However, that is the answer that I am looking for. Okay, that can no longer be reduced. 23 is a prime number and can only be reduced by 1 in itself. Okay. Again, as always, if there's any questions, comments, or concerns, feel free to reach out to me. But again, take your time and at least attempt to figure these out. And then if you mess up, we'll figure out what you did wrong.